Okay, our next speaker, MCichy, is the Director of Computational Design Research at Dialog. Mark supports, in his work at Dialog, Mark supports all design studios across the firm to develop project-based solutions. Mark works with individual teams to build computational design solutions for Dialog's disciplines using software technology that integrates with all platforms. Mark develops internal learning sessions to educate staff on methodologies and tools that provide value in creating project solutions. Prior to working at Dialog, Mark ran a successful design and fabrication company that designed and built complex geometric structures. So please welcome MCichy.
Right. I think this is going to be the antithesis of what we just saw. So I'm here to talk to you about plumbing. So what actually, more specifically, I'd like to actually talk about perhaps the definition of artificial intelligence, or a possible definition of artificial intelligence versus machine learning, and then place that within the context of what is seemingly a very kind of benign infrastructural tool for large organizations. So this is one of the better definitions that I kind of like. It comes from a credible source. The capacity of a machine to imitate intelligent human behavior. That in and of itself is quite a broad statement because human behavior can be wide and varied. Machine learning itself is more, I guess, perhaps the applied collection of data, I guess you could say in a sense. So applying algorithms to kind of comb and grab information. I think what you'll find is within the context of where I'm speaking from today, it'll be more the latter than the former. So I guess to give it some context, and don't worry, I'm not going to go on a kind of corporate tangent here, but this information is actually really important to what I'm speaking about today. And this report was actually done in the context of, say, management and as in like owners, CEOs, managers, project managers within the context of architecture. But I think it also applies to as computational designers or developers, what we end up doing or what they end up doing for most of the day. And I mean, if you've ever worked on a graph that has like thousands of nodes, you do a lot of searching, right? So the idea is to kind of drastically reduce that and to not have to spend your time actually searching for things, but to actually spend your time doing the things that we love to do, which is designing buildings. This shouldn't really be a new thing to anyone in this room. I'm sure many of you have heard of this study, but it just makes perfect sense that we should focus on what it is that we're meant to do and not the benign things that can be automated in a sense. So I guess one of the most painful things within our industry, and I don't mean generally as a whole, because if you think about it, I'm sure we'll actually see a talk today from Eric, who's going to probably present some really innovative stuff in terms of construction. So a lot of people are doing really interesting things in automating construction. There's a lot of really amazing software, machine learning AI based that's being developed for construction as well. But I think generally speaking, there's the amount of firms that are working with AI from a design perspective and engaging technology actually happens at quite a slow pace. Where I'm looking at today in terms of placing this within context isn't necessarily design, but more within the context of, I don't want to say running a business, but operating on a day-to-day basis. So we have a collection of data. It's my little flower pot there on the left, which is our finance, HR, and let's say content, so Marcom, collateral, marketing collateral. In the middle, all of that kind of helps us support us to do our work, which is design buildings. And then on the right, the way we design those buildings is that we use these kind of, let's call them quote unquote advanced processes, which is using computation to actually drive whether it's building performance or design parameters. So that's the context that we're looking at. What I'd like to suggest to get there is that we need to use an unconventional manner to actually solve some of these problems. So some of these things make sense for other industries in the sense that in finance, what I'm talking about today has probably been discussed several times over, but we have to think of new ways to apply it to architecture. So what I'm going to talk to you about is a system that we've built that we call Project Data Lake, which is essentially a deep learning, let's say, collection of tools that we've developed on the backs of some that are commercially available, some aspects that are commercially available, and some things that we've developed ourselves in-house. So what we have essentially are a series of 4 components that we're targeting with this project. One of them is we have these little bots that do all the work. Then we have essentially our master data model, and we're looking at this not from a conventional kind of pivot table and IP tables database structure, but from a graph-based and node-based structure. So that right there gives us huge opportunity. Then what we do is we actually build an analytics engine, which allows us to learn from some of this data. And lastly, what we're doing is we're now tying in our design metrics to this process. So what you'll see is that these things are more closely related than it may appear. So what's of significant strategic value to us, obviously, is the analytics aspect of things. As you can imagine, I mean, our company specifically has, we've existed since 1961. We have a lot of analog content. We have a lot of digital content. What we try to do is to kind of find value in combing that information to help us make better decisions, so that if we know that something leaks, we don't detail the same problem again and again and again, which you might think is common sense, but when you have 800 people working on things, it becomes quite difficult to be able to manage that. So we just want to make sure that there's a level of consistency, but also that the knowledge that exists within is actually shared in an appropriate manner. The other thing, of course, is that, like I said before, there are huge advantages to being able to actually do the stuff that we're meant to do and that we love to do, designing buildings, by automating a significant number of tasks. Like, for instance, we no longer have to actually generate sheet sets or PDFs. That stuff just happens. Pulling information from schedules or organizing sheets, for instance, right? If you're doing a set of drawings and you're organizing a set of like 75, or it could be worse, 1,000 sheets, that could take someone a week to figure out and to lay out. All of this, kind of what this does is allows us to automate those processes and avoid that, and take that time and spend that time on design, right? Investigating opportunity for our client and our vision. And then lastly, I mean, I'd be kind of hiding the fact that we don't look at this if I didn't bring it up, but optimization plays a role in this, right? You want to make sure that you're actually, or we want to make sure rather, that we're actually delivering on our promises to the client, and if we're not and we're off budget, well, we're off budget, but we need to understand why that is. So these sorts of engines and the software that we've developed to be able to track these processes helps us determine where things lie. So here's a quick kind of overview of kind of how the system works. We have harvesters, crawlers, a refinery, a processor, and analytics. What's really interesting about this, and I think I was just having this conversation yesterday with someone, is that the concept of a mainframe back in the day used to be the big thing. You wanted to kind of like put all your eggs in one place and let as much hardware processes as possible. Now we're actually thinking about quite the opposite, right? So it's like distributed computing. We want to make sure that we split these things apart. They're very specialized tasks as opposed to one thing that does them all. So as you can imagine, with 50 or 60 years of history, there's a lot of work that needs to be done because we're just pulling stuff in now too. But not only that, you could be working on a project that is 4 million square feet of building space, and I don't know if any of you guys have ever, I'm sure there are Autodesk people in the room that have reverse engineered a journal file because they wrote the software that created it, but if you've ever actually looked at what's inside a Revit journal file, it's insane. So every object in that model is defined some way by the variables or parameters that reside that allow it to be created. So what we can do is we can actually comb with all of those little things that I just showed you, the refinery, the crawler, we can actually comb that journal file for data that we need to extract or manipulate or change. So we can actually start to build intelligent systems that flag issues for us. Not only that, but there's a tremendous amount of value that we can automate tasks nightly based on conditional statements. So what will happen is that if there are geometric conflicts between structural or mechanical, overnight we can run these processes and generate PDFs that actually highlight what the issues are and then review them and address them. So what this video is essentially meant to show is the web portal. And what you'll see here is there's a tremendous amount of information. In this case, what we're doing is we're working on something as benign as a patient room. And so the room, you'll see the bubble once we actually fill the query, the Cypher query, is that these bubbles pop up. So what's happening here is as the rooms are being added to the project and walls and toilets and sinks are being added, you're seeing that purple object being the room, and all those little pink dots are actually the elements within the room. So the drawing and the content within the drawing is actually showing up in the database, so we can see, oh, wait a minute, somebody forgot to actually put the hardware and everything in this room. We should really go back and address that. So conceptually, I'll just go through these really quickly, actually, because I'm going to zoom out. You'll see that, one more, these can get pretty dense. So you can imagine in your mind these sorts of connections are obscenely difficult for the human mind to try and figure out or be able to categorize what the associations are. So what you're actually looking at right now on screen is a dynamic growth, the system learning and developing the graph and the relationships between objects, not just objects, but people, finance, all of those things I was talking about, and the geometry itself. So as the project grows, new people are added or taken away, this graph is dynamically adapting itself to those conditions and changes. What we've done in addition to that is we've gone ahead and we've automated a whole bunch of things. So the next slide's actually, I should have put that one first, but essentially what you're seeing in a web browser right now is the infrastructure behind all this. So what we have is we're running on a containerized system like Docker. I'm sure some of you have heard of that before. It's a little whale logo. It's pretty cool. Essentially allows us to create dynamically like virtual servers, but isolated containers of software. So we can essentially develop these apps and launch them on a kind of, not a hypervisor like you would get with a virtual machine, but like a virtual layer on top of an operating system. And we can just move these containers around across different servers, depending on whether it's Azure or AWS, and there's no downtime. So they're constantly cataloging information. In this case, what you're seeing is we're doing a drill down search for some drawings and details on a specific project. And all of this information is being ingested in real time and being crawled and combed by the deep learning algorithm. So when we're having chats internally on MS Teams or Slack, all of that information is actually being ingested. So here's essentially, I'm not a software engineer, but this is the best I could basically illustrate for a stack that we're using. So essentially at the very low level on the bottom there, what we have is a server somewhere in some cloud, right? So we have our own cloud system, then we're running Docker on top of that, And Kubernetes and Rancher essentially allows us to populate and create copies of those containers and deploy them really, really fast and interconnect them and see what the relationships are. So then we have our software layer, which essentially addresses our graph database. And on the right, we have our tie-ins for all of our applications. So all of this is combed by the AI and deep learning algorithm, which sits on top of that whole entire system. But it also is able to interact via Speckle, which Dimitri spoke about yesterday, with a whole bevy of three-dimensional systems. So we can use Grasshopper, Dynamo, Unity, SAP, C#, obviously. What's amazing is that it's a schemaless system, so you don't have to worry about the schema until you actually send the information. So it's the receiver and the sender that actually matter, and not so much the server itself. So lastly, this is one of those graphs I was talking about. Incredibly dense. You can imagine if you're trying to find stuff, you're trying to explain to someone how to find this, find something in here, it'd be a little bit difficult, right? So I'm just going to make two last comments. How does this relate to architecture, I guess? So we've developed an initiative that is essentially not actually too much dissimilar than what Sidewalk Labs is doing, but studying how communities actually grow and what makes a good community and what are the metrics that actually define how those communities grow. And so what we're doing now is we're actually deploying the system that we've developed initially for things like getting all of those really banal elements of our practice in order and starting to apply that now to design projects. And in the case of the communities, it's actually creating some really interesting connections, like that graph you saw with the rooms at a scale of a city is quite a bit different and very interesting. And so at the end of the day, we're, in the business of making buildings, and we're just at the beginning stages of trying to figure out how this technology that we're developing is going to help us make not necessarily better buildings, I guess that's part of it, but maybe more interesting buildings that are more in line with occupants' requirements. So lastly, this is essentially what the interface looks like. It's deliberately simple. What's really cool about this is that in the very near future, what you're going to be able to do is insert a query into that search bar and say, connect that to a Grasshopper script. So you've got a model running on a project and you want to know what the performance values are. If you change the window to wall ratio, you can actually send it a query that says on project and put in the project number. Show me what the solar radiation values are on the north envelope of the building with a window wall ratio range of X to Y. And it'll actually generate the images and send that back to you in the browser. So it's going to run a headless Grasshopper script and then provide you with the visual results, which I think is pretty cool. So